resistor, be an inductor, and they'll say the impedance of the total network is, and again, it'll be some value R and some value X. In this case, it'll be a plus because it's inductive. In this case, it'll be some value R, like 100, minus, because it's capacitor and it's on the negative side of that axis, minus J, 100 if it's the same impedance. That's the simple thing you have to remember, is that part. Then they'll talk about something else called power factor. Okay, let's explore that one just for a minute. Power factor, boy, that sounds simple in words and difficult in concept, but it isn't. We have a voltage, and maybe for the sake of being colorful, we have a current in a circuit like this. And the voltage is going to lead the current, Eli the Iceman again. E comes before I in Eli, where L is the middle letter. So this is as an inductance, and therefore this is your current showing up a little later than your voltage does. E or B, pick whichever one you want. Well, what do we know about power? We know that power, by definition, is E times I. Okay, at any point in this curve, if you were to multiply the value of E times I and you averaged it over the whole cycle, if you've got a 90-degree phase relationship, meaning when one thing is over here, the other thing is down here, and when the other thing is up here, this guy is at 0. In other words, you've got this vector that's, or phasor as it's actually called, that's rotating counterclockwise through a cycle from 0 degrees to 90, 180, 270, back to 0 again, which is the same as 360. And he averages 0 because whatever your voltage is maximum, your current is minimum. And whenever your current is minimum, your voltage is, whenever this voltage is minimum, your current is maximum. They're always 90 degrees out of phase, which means your power will always be 0. When you have a capacitor, or you have a pure inductor, I'm going to say pure because inductors are made of wire, want to run a coil form. Wire has resistance, so it's never purely inductive. There's always a little resistance in there. But imagine for a second that it's negligible compared to the inductance. Whenever you have pure capacitance or pure inductance, 0 is the power that you will dissipate. Why do you dissipate 0 power? Because you're putting it in, you're taking it back out. If you have a resistor, the two are in phase, and the E and the I always travel together. Okay, what if it's something else? What if it's all the above? You got a capacitor. Or what if it, no, let's just for a second just argue that, okay, it's somewhere in between. You got some value of R, you got some value of X. Okay, therefore, you're going to have E times I, but you have another thing. There's actually a third term in here that wasn't talked about before, and it is the cosine of that phase angle between them. This angle here is the phase angle. The phase angle is the time delay. If you have that situation, you don't have 0 power, but you don't have maximum power either. More specifically, let's draw a little picture of a circuit. Here is an AC source. Here is a resistor. And here is an inductor. like you would have in a motor, where you got some coils in there and you got some inductance, you got some resistance. And I put in a couple of meters here. Out here, I put a voltmeter. I measured the voltage across this leg. And in here, I'm going to put an ammeter. I measured the current through this leg. And in here, I'm going to put a wattmeter, which actually measures it actually does the multiplication of the voltage and the current, and also handles the little business of the phase angle between them, because intrinsically, one coil in the meter is energized by the current, one is energized by the voltage, and they call that the pressure in the current coil. And if they're not in phase, then the magnetics between them that make them needle deflect will adjust itself accordingly. So if you happen to have a situation like this where you've got 10 amps of current, 10 amps of voltage, and you normally would have a power of 10 times 10, or 100, but the wattmeter says he's only getting about 75 watts. Something's rotten in the state of Denmark, right? No, they're not in phase. The phase relationship here, this cosine theta, is referred to as the PF, the power factor. It is the cosine of the angle between them. And yeah, there will be a question or two on some of these tests that you will take if you're going for general or extra that will say, if you have this many ohms of R and this many ohms of X, what's the power factor? And the power factor will actually be, let's just, for the sake of saying, they're each 100. The power factor will be will actually be the length of that vector, which will be determined by the X here, excuse me, the X value here and the R value here. And what is that? Remember Pythagoras? This is your vertical value called Y, here's your horizontal value called X, and this is your hypotenuse, which we'll call R. And the sons of the square of the hippopotamus equals the square of the hippopotamus equals the sons of the squares of the other two heights. Remember that story? Come on, it's a pun. There was a Christmas party in the Indian teepee. Squaw gave birth to two sons, and she put them on a hippopotamus hide. And there was another squaw with a bear skin that had one son, another squaw that had one son, put it on a shark skin, which means the sons of the hippopotamus equals the sum of the sons of the other two. Never mind, you know the story. Yet the rule of Pythagoras says R squared equals X squared plus Y squared. Theorem of Pythagoras, the square of the side adjacent plus the square of the side opposite is the square of the hypotenuse. So you have the classic 3, 4, 5 triangle. This is 3 inches, that's 4 inches. This has to be 5 inches. Because 3 squared is 9, 4 squared is 16, 9 and 16 is 25. The square root of that is 5. You remember that, don't you? Okay. If R squared equals X squared plus Y squared, then R is equal to the square root of X plus Y, which means to solve this problem, the power factor is actually the square root of the R value and the X value. Take that and square it, take that and square it, add them together, take the square root. That's your power factor. That will be a number between 0 and 1, which will equal the cosine of the angle between the two phases, the phase delay caused by the fact that you have inductance and resistance in the same place. I don't hear any questions, so I'm assuming either a little bit of this or everybody's saying I'm cool with it. I'll hope for the latter, and when you go home and tinker with this, you'll come back and say, okay, I tried to do one of those question pull things and I came up with one of these situations, so I still don't get it. No, we'll go over it again. But the only way to analyze what you got when you got a resistance and a reactance in the same circuit. They're going to affect the timing of when the voltage starts and when the current starts over each device. The current will lead the voltage, and then across the capacitor, the voltage will lead the current across the inductor, and if you have a resistance, it will pull it back a little bit from the 90-degree shift that you otherwise would have. And the way to describe where that ends up is on this diagram where inductance is positive, capacitance is negative, R is always positive, there's no negative resistance in a real world. There's something called a tunnel diode that can kind of simulate it, but we won't go there. And where they intersect is the place on the rectangular plane or the polar coordinate system plane that says either at some angle and some radius from the origin, or some value at R and some value X. I'm out there in space where I've got a little bit of resistance, a little bit of reactance, and that's my impedance. It's a mixture of both. And there's a power factor because there's a phase delay between them. And let's compute that power factor, which affects power, because this times this don't work if the two aren't really timing together. They're kind of delayed relative to one another. You have to put that together and come up with that way of approaching the problem. Again, I wouldn't do it except that I know the stuff's on an extra class test, and I'll prove it because we're going to have our coming schedule. Remember, I'm going on a trip to Paris tomorrow. Yay! And here it is, the 5th of November. We don't meet again until 26. How do you remember this? It's just before Thanksgiving, so before you stuff yourself with turkey, stuff yourself with the questions. But you have 2 weeks to actually sit down and kind of punch the numbers and figure out, okay, I'm going to catch my breath from all this stuff. I'm going to read the book finally. I'm going to look at the question pool. I'm going to solve these problems, and if I can't solve them, I'm going to come up with questions. And that's what we're going to do on the 26th. We're going to answer some of those. And if there's no questions, I'll cover a few other miscellaneous topics. Because we've got one other session on December 3rd. December 10th is the test. By that time, you either know it or you don't. Believe me, this doesn't show up on technician test. Technician test questions are more questions like 40-meter band begins at what frequency. You know, you got this little chart in your handout that tells you the answer to that. 7.0 megahertz, and then it's 7.3. You can't really teach that. You have to read it and memorize it. But they're easy questions.
So the test is here?
Yes,
Do we
this
need to
room.
Pre-register?
No, just show up. In fact, I take walk-ins. People that didn't take this course at all, welcome to come. That's kind of the, not the rule, but the philosophy of ham radios, that you should have open sessions. Some of them are closed because you have to have access to a building that the test is being taken in, and security being what it is. You can't help it, but as often as possible, the test should be open to the public and advertised. And mine is. If you go on the ARRL's website, it is listed in their calendar. And my contact information is there, this location is there, the date is there, the time is there. The $15 fee is not there, but it's in the other parts of the ARRL website. Yeah, you gotta bring 15 bucks. And a photo ID. I think everybody here can handle that one. The fee is not for the FCC, the fee is not for me, it's for the American Radio Relay League, which has to process your paperwork. That is, it takes all the forms that I send in that says, okay, here's the sheet with the answers that this person gave her, what the 3 examiners rated it to be. There are always 3 examiners that will grade everything. Those 3 examiners will also sign the Form 605, which is an FCC form, which has your name and address and other information. And the ARRL takes that and puts it in electronic form, sends it by internet to the FCC using their secret access, and your license becomes available within 24 hours online, meaning you can go to a website for the FCC, or you can read one of these daily reports from the FCC on qrz.com, and voila, discover what your call sign is. Or you can wait a week after that and you'll get a paper ticket license in the mail from Gettysburg, Pennsylvania, which is the FCC's license processing center.
It's about 7 to 12 days,
So
depending
that-
how
yeah.
busy they are.
By the way, the blur all gets backed up sometimes. I used to get 24-hour turnaround, sometimes it take a week. You know, I just go crazy. People call me and say, hey, I didn't get my license yet. Patience. You hit them at that moment. Winter is always worse than summer because that's when people tend to go indoors and forget their boating and swimming and start taking ham radio classes.
So when I took my tech test, which was last month, it took me about 10 days to get my call sign.
I would think that's normal, okay?
Yep. I then applied for a vanity call sign,
Okay.
and it's been going on 2 weeks. Is that normal, or is that excessive? Should I
yeah.
call them?
I've seen vanity call signs take up to a month.
Oh.
Now, let me talk about what that is. You can get a vanity license plate in Illinois and a lot of other states for your name, and, you know, it's all letters, no numbers. Or a personalized plate for a much lower price that you don't have to pay a premium on every year. That's got, you know, my wife's got one, BONNI for her name and number 19 next to it. Ham radio does the same thing. You want a call sign that's got your initials in it? I had WNRAD for a while. And then the guy Bob Davis, the guy in Northwest Indiana, passed away and had K9RD. And I said, that's the call sign. I applied for that one. So I've gone through 3 call signs. I started out as K9ZEH, issued in 1960 in May. That was my original name. So, yeah, you have to get your sequentially issued call sign from the government first. Then you can say, okay, I